Okay, everybody should get a notification that it's okay to record. We will get started. First of all, welcome. Thanks very much for taking some time today. This is meant to be the very first seminar that we're holding. We'll hold at least 3 of them that are going to introduce the software challenge for the ARTEMIS Leapfrog project that's actually coming out of NASA. We have probably communicated with a number of you previously, or you have seen the things that we were doing. We had to actually make some modifications relative to what was happening with the COVID landscape. So you're going to see the result of that today, and we will introduce you to what we're doing with the software challenge. We will really try to keep this to an hour. We know everybody's time is pretty important and everybody's in class. We respect that. We want to try to get as much information out as possible. This is being recorded, and it will be put up onto the website with a link that you'll be able to go back to, so that in case you miss some things today or other folks come on board, you'll be able to see that. So let me just check, is everybody seeing the slides and not the presenter view from my PowerPoint? Okay, cool. All right, we are off. Real quick, going to give you some background just in case. As a reminder, Leapfrog is one of the 3 Theme 3 2020 awards that came out of NASA. It was related specifically to the idea of a lunar and Martian lander skills, competition, capability. We wanted to emphasize systems engineering and integration and hands-on thinking skills, as well as how do you merge software activities related to an actual hardware program. Our new goals, in essence, if you guys had remembered, we're going to do this big national competition with a bunch of vehicles flying in different places. It was just really tough for us to see if we would be out of the COVID activities and therefore not be under restrictions in the 50 states. So instead, we backed off and changed a bit. So what we're doing now is we are doing the upgrade to the Lunar Lander Leapfrog vehicle. We are also doing a competition, which we'll talk about today, that's specifically focused on software. And we are going to run and do some hardware activities in the summer, but it's not quite as extensive as what we had proposed. Although we are planning to get you, i.e. the teams doing this, hardware kits, something we hadn't necessarily thought of previously. So this is actually a good thing. My hope is a quick note on the timeline on what's happening. So we sort of put out the software competition announcement. We are now in the concept of running the signups for all the potential teams. We are in the phase of doing simulation and updated webinars on what the software challenge is, which we'll talk about today. The first seminar is today, and today really is just to introduce you to the tools that we're proposing to use for the software challenge, not get into the details yet. Those will be outlined in seminar 2 and seminar 3. And as required, if we get a lot of questions, we can add seminars to this as we go forward. The plan at the moment is to run the actual software challenge between May 15th and June 15th. The idea was to try to not eat into the entire summer, but not to pull it back too far into typically what the semesters are for most schools. We also recognize that that time frame may actually still have schools in session, and it may also be sometime in the potential finals time frame. So it was tough to sort of find a time that would make everybody happy and not interfere. We would like some feedback from various teams about, yeah, are some times in there better than others that we might want to deal with. The idea after the software challenge is to sort of finalize them, contact the winners, and the new thing that we're doing is actually to take the top 3, possibly the top 6, and send out a hardware kit, which is basically the Leapfrog vehicle without the jet engine, to all the teams. And then over the summer, our plan is to actually run some what we're calling vehicle boot camps to build the vehicles. We would be on Zooms with you all maybe during a week, and we would go through how to build the vehicle up, how it all works together, so that you'd have your own vehicle at the end of that time frame, sans the engine. That's the one thing that we did not get approval to send out to everybody. And then we will plan to have some exhibition flights that will be flown here in the California region. And then the hope is we take the top 3 winners of the software challenge, and we actually host their software on the vehicle and fly it, very similar to what we had originally planned for. So in a nutshell, that's what we're trying to accomplish and trying to put together. It's a lot of activities. We think we can do it. So anyway, we're getting excited for it. Big picture again, the new activities that we're doing on the left-hand side, the virtual software challenge, which I won't go into any details because the students are going to give you more details on that. That's happening between roughly now and June timeframe. So we're getting a lot of information out to everybody. The idea is to actually have you begin to get familiar with software that would actually fly on the vehicle and run a simulation challenge, which would provide some inputs to one of the navigation features. And then sometime between June and August, we'll do these boot camps that we call basically building, and we'll do some flight exhibitions. So that's sort of our new plan and what we're doing. Again, we were responding to some uncertainty associated with COVID and trying to do the best we could to not potentially set up large events where unfortunately we would potentially have a lot of people working together on it. Very briefly, again, all these charts will be up on the spreadsheet. You can look at what Leapfrog was. It was something that we were lucky enough back in 2006 that USC put together, and it was really meant to be something similar to what the CubeSats were for Cal Poly. It was to teach students about systems engineering related to a lunar lander system, utilizing an RC jet engine to essentially take out gravity. We've had flights. You guys can see those on the website. I won't go through those today. We are upgrading the vehicle with a bit more safety and ease of operations capabilities. Let's see if I can ask folks to sort of mute. There we go. Yeah. So again, you'll get more details about this as we go along, about what the vehicle really looks like. And in essence, this is going to be the thing that you all will get without that thing in the middle, which is the engine. We are in earnest. These are old pictures, but we'll get new ones. The vehicle is now almost all built up. We actually have our first hot fire engine test planned for either this weekend or next weekend. So we are on track to sort of get the thing up and flying and operating correctly. Again, you will get basically what you're looking at there as a kit, again, without the engine. And at least that's the new activity that we're doing from our project plan. I won't go into details on this because the guys are going to talk about it here very briefly. But in essence, what we're describing to you today is our methodology by which we merge the hardware that will fly on the vehicle with a methodology to allow you to simulate it, and then code that would actually fly on a piece of hardware that is synonymous with both. So that's the Pixhawk device and the PX4 controller that you actually see there, that we will actually have on the vehicles. So you're going to be running simulations that conform to that environment that eventually would port to that actual processor that would be on the vehicle. So that's how we're sort of linking what we're doing with the software and what would eventually be on the hardware that actually flies. I won't go into the details in this. You're going to see a lot more details about how the team actually has come up with the simulation software and how they put it together. So I'm just teasing you here for the moment. The particular flight challenge scenario, we will not go over today. Today, again, is just the tool sets that we want you to become familiar with that will be involved in the simulation challenge. The actual scenario about how it's all sort of put together and implemented in the simulation, we will go over in seminar 2. So that's why we've broken these seminars up into sequences. And then in seminar 2 and in seminar 3, we will convey to you the methodology by which you upload your software to our GitHub or our storage location that we then run the simulation challenge and then do the scoring for as we go forward. So we're still working those things out, trying to get all the portals set up correctly to make sure that you all can have connectivity to it, and therefore we can have the software that comes together. Real quick, you can get more information, which we are constantly going to be upgrading at the leapfrog.is.edu website. That's where I'm hoping many of you got the actual registration link. We have now gone from pre-registration to registration, and this is the actual link. So you'll see that it's a Qualtrics access page, actually from one of our students at Berkeley, which is great. And then you go in there, and when you sign up on that then populates a live page that we have for your teams actually being registered to actually go forward. So we appreciate that very much. I won't show pictures of the students that are on the team. You can actually go to the website, and all the student pictures, or most of the student pictures on our current team, are there. So then you'll know who is sort of talking and who's supporting that on the particular teams. For specific contact, we do have a email address, leapfrog@usc.edu. That's the one that I actually sent out this notification for the software challenge from. If you need to get in touch with one of us directly, my email is listed there, as well as the programmatic, the PI, John Kosmatka. But we prefer that you use the Leapfrog email site, because that's going to be looked at by a number of students, and therefore we can accommodate and send the answers as required to go where it needs to go. So with that, I'm going to stop my sharing, and I will hand it off to Garrett, who I think is going to be leading the effort from the software standpoint to introduce it. The students that you're looking at on the screen are the ones that are going to go through today's presentation for what the background is. There's a number of other, obviously, student teams that are working with us specifically. Town also sent out the survey link specifically for signing up on the registration in the chat box. So thanks very much there, Town. Okay, so without further ado, I'm going to hand it off to Garrett. And we will have enough time afterwards to go through questions, because that is one of the principal things we want to do today, is to be able to answer as many questions as you have. And then if we need to add additional information when we put things up on the website, we will do so. So thanks very much, Garrett. Go for it.
All right, thanks for the intro, Dave. So thanks for coming to this webinar. As you said, we're going to be talking about specifically just the simulation environment and what the challenge is going to be inside of this environment. So as a teaser, this is actually a render of our actual vehicle in the actual gazebo environment that we're going to be using. And the actual background and the environment that we are using is directly from a NASA 3D model of one of the actual landing sites from one of their trips. So for the actual presentation, we're going to be going over the software challenge and how it's specifically going to be handled by us. Then we're going to talk about the actual vehicle systems that you guys are going to be interacting with, so you get an understanding of what you have control over and how it actually is going to work. After that, we're going to move into all the actual tools and all the actual applications that we think are really going to be necessary and very helpful in order to accomplish the challenge. Once we understand all the tools, then we're going to kind of explain how all these things come together. So hopefully that'll give you guys the basic understanding, so in order for you guys to look more and understand what to do. We'll end with a little summary and open up some questions there, so we can get some feedback from all of you guys. So then I'm going to pass it off to Andrew, who's going to talk over some of the challenge overview.
Yeah, okay. So for the actual challenge of like what a competition team would be trying to accomplish here, kind of two main aspects to this. One of them is going to be kind of like dynamics and controls oriented, where there are going to be a couple of key controllers that are not fully implemented in the or not implemented in the simulation. So it'd be up to the competition team to design these controllers and implement them in the correct location. And the second aspect is a navigation aspect, where the competition teams can be trying to develop this navigation algorithm that is trying to like optimize time, fuel usage, and the highest or maximize the projected score, essentially. Yeah. And so for the actual system, these are the actual actuators you have to work with. The primary one here is the engine. It's, as you can see on the right image clearly, it like right in the middle of the lander. That's where this engine is, and it's capable of producing a maximum of 300 newtons. And so this engine is this is the engine that will be used for translating and providing the primary thrust needed to navigate the vehicle. This engine is on a gimbal system, and this gimbal system is controlled by two linear actuators, one for each axis. And these linear actuators have a saturation force of 900 newtons. And then lastly, in addition to that, there are 6 cold gas thrusters on the outside towards the outer edges of the vehicle. Um, 4 of them are facing downwards, 2 on each axis. So 2 correspond to roll, 2 correspond to pitch, and 2 of them are oriented sideways for yaw control. So for actual flight software, what we're using is a variation on the PX4 software. And so what is PX4? So PX4 is an open source flight control software that is really popular in the drones and unmanned vehicles community. And the reason for this is it's very modular. It's easy to expand, and that actually was really important for our situation here because we had to extend PX4 for the Leapfrog system. And so so you so on the bottom here, you kind of see a block diagram for like the base PX4 architecture. And so you can see that there are several controllers in series, and it provides its own navigator and position controller. There are some changes we had to do, like we had to remove the attitude and rate controller and replace it with our own controllers. But yeah, this will be covered more in depth in other things. Yeah, and so for the in order to approach this simulation, we're using the concept of SITL, or software in the loop, and this essentially means that we're running our flight control software and separately a simulation environment in a single loop. So yeah, so for our case here, it means that we're running our variant of PX4 as our flight controller, and this information is constantly in a loop being fed into our simulation environment, which then gets fed back into our the information from that gets fed back into our flight control software.
So moving on to Mavlink, this is a very PX4 software suite. So in this case, we know that PX4 uses Mavlink because it's a very lightweight communication protocol. And this is very important because most of the transmission is wireless. And then it's actually optimized for transmitting different kind of information that pertains to vehicle. So as we know, telemetry data is very important for vehicles, but at the same time, we need to configure parameters as we are setting up a autonomous vehicle. And then it also provides large extensibility for different languages, and this is very important when one is trying to develop plugins that not necessarily are within the same software framework. So as we kind of hinted, we're using different software frameworks that perhaps are optimized for a specific language. And then moving on to Gazebo, this is another portion of the SITL that PX4 provides. So this is a physics engine that it's very versatile and gives a lot of support for developing new plugins. So this was very important for us because we had to develop some controller plugins for the extensibility that we were giving to PX4. And then we also had to develop some scoring plugins that are specific to our competition. And then at the same time, there's this paradigm for creating new worlds, which is very helpful as we need to develop different environments for our competition. Lastly, we also have other visualization tools. So Q ground control is specific for mission planning. It allows for configuring the vehicle. So as I previously mentioned, we have the Mavlink messages, and Q ground control is basically just a way to visually represent all the information that one is receiving from the vehicle, and one can manipulate the information accordingly to what needs to be addressed. And then we also have plug juggler. So this is specific to the ROS environment, which we'll cover later on. But this is very important for, well, in our case, we tend to use it for tuning and more of the, I would say like well, not bare bones, but like more specific or more technical task that we need to do. And it's very convenient because one can visualize different types of data at once and across time.
Yeah, so the last major tool and framework that we're going to be recommending to use is ROS, and also specifically MavROS. So if any of you guys are familiar with robotics frameworks in general, ROS is probably one of the most widely used, if not the most widely used robotics system just across the board. It allows you to easily create different tools, libraries, and it has a whole series of applications that are very useful when dealing with robotic systems when you have different hardware, different networks and interfaces to connect all those things. And one of the major advantages of using ROS specifically is that it has a centralized communication system that relies on a pub-sub, a publisher and subscriber system, where you can just send information between any ROS compatible node by just specifying a specific topic name and a specific message type. This is going to be very useful for actually extending the PX4 framework and creating your own navigation algorithms, because communication between PX4 and your external navigation system is going to be as simple as just specifying a topic and telling PX4 and ROS to look at that topic. And MavROS is the specific ROS node that you would probably be using to do that, because it is specifically a Mavlink node that's already been created and also created to work directly with PX4. So it just allows you to very easily extend and do whatever algorithms and whatever applications you want to create. So then moving on to how everything actually comes together and works. So now that we actually kind of talked and went over all the individual components, it's a lot of different things, and hopefully this diagram and me explaining will kind of break them all down. So it's really broken down into 4 major things. We have the PX4 that's going to be running in the CIDL mode, CIDL configuration. We then have the simulator that connects to this, which is Gazebo in our case. We have Q ground control, which is just really going to be used for analysis and also helping some mission control options. And then we have whatever offboard controls that teams will be using to do the actual navigation and complete the actual competition software challenge. So the PX4 in CIDL mode, what's important to know about this is how it's different from just the normal PX4. So the normal PX4 is designed to run on the commercial PixHawk board, and it's specifically meant to be compiled and loaded onto that. But when you're working in just the simulation, you don't need a lot of the same hardware tests and main controllers that are all necessary for the real hardware. So when it runs in CIDL mode, it just disconnects the unnecessary things and substitutes it with simulated versions of it that are meant to recreate as best as possible all the necessary tests and sensors that will create the realistic environment. In addition, in this mode, it still works the same way as PX4, where it communicates externally just using the Mavlink protocol that we talked about earlier, as well as the actual Mavlink messages. So in this diagram, we can kind of see we have the PX4 CIDL on the left side doing all the internal work, and then all external communication across the board is using the actual Mavlink protocol. So moving on to the simulator itself. So the simulator Gazebo is really just the environment and also the physics engine that drives the environment. For our case, when we have the actual lunar lander, because it's a custom vehicle, it's a custom 3D model with our own control system with the ACS and the TVC, it's going to need its own custom plugins to tell Gazebo, tell the simulation environment how to actually control the thrusters and control the engine, control the linear actuators for the gimbal. In addition, the Gazebo environment does allow you to actually add in your own sensor plugins, which allows you to control exactly what type of IMU data you have, control the actual noise for that and the fidelity of it. In addition, since it is simulation, you do have access to all of the real ground truth values, which should hopefully help in actually tuning the controllers and tuning the vehicle, because you can always reference the exact state of the vehicle as it's moving. One other sensor plugin that we've added in, or we're going to be adding in, is going to be a laser sensor that's going to be pointed down just to get the altitude or the relative altitude, which would also be very helpful for the navigation task. So once we have the simulator stuff set up, then actually testing and tuning and completing missions is really easily done using Q ground control. So Q ground control is just a standard ground control system, but there are others that exist. The main reason that we recommend to use Q ground control for this is because it's cross-platform and very easily installable. It does just connect to PX4 via Mavlink, and it kind of does this automatically for you, which is one of the main reasons why we wanted to use it. So once you actually start up PX4 and start up Q ground control, it should just automatically connect, and you should get all the necessary feedback you need and see the actual status of it. And then finally, the last part that's really important is, how do you do any off-board control? How do you actually write the navigation algorithms, and like where is that located? So the communication aspect between your off-board algorithms and PX4 is the Mavlink protocol here. So what that means is you will be sending just Mavlink messages between whatever off-board control algorithms you write and the actual PX4 environment. That's why we recommend using MavROS, because it just allows you to send those a lot easier than other Mavlink libraries that we found in the past. But by using ROS and MavROS, you should actually be able to write whatever navigation algorithms in pretty much any way that you want. They have bindings to create this algorithms in C, C++, Python. They have some MATLAB bindings as well. So you can really just put your off-board control, your guidance and navigation algorithms anywhere, make sure it's just ROS enabled, and then just send those messages directly to PX4, and it should respond and do whatever you're telling it to do. We've had some links scattered throughout here that are going to detail the actual PX4 documentation. So in addition to like just these diagrams, if you want to get like lower level information about everything there, you can always just check out the docs that they have there. So that's all the main components and all the parts that we wanted to break down. So in summary, what we've really talked about is like, what is the actual Leapfrog vehicle? What is the systems that control it? And how do those actually work? Went over all the individual tools. So PX4, the main autopilot controller, the CITL software in the loop environment itself, the Mavlink protocol that really connects PX4 to everything else, which includes Gazebo, then also ROS and MavROS, as well as Q ground control. And plot checklist can be really crucial for tuning controllers, because you really want the visual feedback. And then hopefully we also went over how these major components actually link together in the simulation environment. And with that, I guess we'll kind of just open this up to any questions that people might have.
Awesome. Thanks very much, Garrett. That's great. Yeah, so I know you can put a question or in the chat, or you can just sort of raise your hands. It's open at this point. So let's see, while you guys are formulating questions, just to clarify the sequence of how we'll try to get the information out. This particular seminar was meant to provide you the input to the simulation environment and the specific software. The attributes of the vehicle itself that are loaded into, that allow the system to actually run, will be provided and talked about in the second seminar. So we'll go into more details about how the vehicle itself has been modeled inside the simulation environment. You know, how the actuators are actually set, their physical location in the model relative to the simulation environment, the axis coordinate system, the real world, if you will, that is modeled by Gazebo that the vehicle flies within. So we'll get into all of those details and actually run through an example in seminar 2. And then in seminar 3, a little bit in 2, but in 3, we'll go through how do you actually upload the code that you've created. And then also we'll go through sort of the scoring criteria relative to what we're seeing in terms of the challenge itself. So those are the backgrounds. Okay. We will have, as we indicated, we will have this information, both the presentations that will have all the links in them so that hopefully you'll be able to just click those things and go and hopefully download the software, as well as this, this presentation will be loaded up so you can look at it again.
Yeah, in addition to just like this presentation, I don't know how we want to link this yet, but we also have more detailed documentation and documents that break down everything a lot further in detail and provide all the better links to like everything that we found that we think could be a lot more useful. So in addition to this presentation, you guys will also have access to that documentation that we've made.
Got it. Yeah. The question came up, which was a good one. Maybe Garrett, you can indicate it. Where do they get the software?
Yeah, so once the teams actually sign up and we get everyone that is in the competition, what we've done is set up a GitHub customer environment and GitHub organization where teams will have to create their own team on GitHub. And then once you do that, it'll automatically give you the actual like code itself and exactly what you have access to for the simulation.
No, well, I think that's one question, but the second question is where do they get the PX4 software, the ROS, the Mavlink, that kind of thing?
Oh, okay, I see. So in the other more detailed document, we do have more links for that. In the webinar too, that's when we are planning on like actually breaking down exactly how to install, download, and set up everything. So for that, like we will be going through exactly where everything is and like literally walking through how to set up everything together.
Okay, well, so the first thing though is if you go back to any one of your charts that you had a link to it. Yeah, like right here. So this.
Yeah. So this link should just link back to, I don't know if you guys can see this now. This is just the PX4 document or the PX4
the user
itself.
guide.
Yeah.
Got it. Okay. But the PX4 the simulation itself, there's software there that I think that was the first question we need to start with, is where do they get the software and how do they load it onto their machines? Or I mean,
yeah. So like the PX4 software that we're using is the one that we have currently configured to be automatically sent to people on GitHub when they sign up.
I see. Okay.
Because so like they have like PX4 is open source and they do have the official GitHub repo that like, anyone can look at, but that doesn't have our configurations and modifications for it. So like our configurations are on the actual Leapfrog GitHub organization.
Got it. Got it. Okay. But if they, I mean, this presentation was meant to convey these are the tools that were used, and ostensibly they can then go in and get familiar with the tool sets. The particular instantiation of the simulation we want to run, that's where we'll get them a connection to the GitHub.
Yeah. So I guess we could also right now our actual version of PX4 is a private repo, but we could just make a version of this that's public, so you guys will actually be able to see now exactly what you would be working with and have access to. So we'll make sure to do that and also put the correct link for that when we release the actual PowerPoint presentation.
Okay, so I think we have one action that we'll probably do is to consolidate all of the links that you can go to get information about it, and we'll be able to put that in an email. So I can send out. The second methodology is we will provide all this on the web page, and we'll update the web page here in the next day or two so that all of this information will be there. It does sound like in order to get them actually up and operating, or at least familiar with these tool sets as it's applied to us, we have to get the detailed document out to them. So the question, Sarah asked the question about how do we get the access data documents? Those will also be on the website that you can go click and you'll be able to download those directly. Got it.
I think we have a question from Sarah.
Yes. So I was looking at the email that was sent out, but I don't see a link to GitHub. So I was just going to ask about that.
It wasn't put in because we were still setting it up. So
oh, okay, no worries.
You didn't miss it. Yeah.
Okay, sounds good.
That's on our action. We're moving pretty quick. So we're yeah. We wanted to get first. We wanted to get this out. We wanted to get the information out. We wanted to communicate to everybody who was interested. And you know, we're still sort of building the connectivity that you guys can have. So that's coming out. Yeah.
No problem. Thank you. I was just trying to make sure that I didn't miss it. Thank you.
No worries. No worries. Okay, got it. Well, let's see. I don't want to keep folks. Definitely don't hesitate to send emails via the website, or sorry, via the email, the leapfrog at usc.edu. It will get answered. If you could, we will have everything up on the website no later than Monday. All of this information. We're going to try to have sort of constant rolling updates as we consolidate all this stuff, put it into the right bins to make sure that you guys can download it correctly. So give us a few days, but we will definitely get this up so that way you can at least start getting access to these documents, being able to go to some of the websites, begin to get yourself familiar with the PX4. That has a nice user's guide to it, because again, that's the link between the hardware and the software that would be doing at least some of the controls algorithms on board the vehicle. And then as Garrett indicated, we will get a GitHub set up so that you guys will have access to it. And then you'll be able to begin to pull some of the specific instantiations of how we're building at least this lunar lander simulator in those environments, so you can download them. So awesome. The other thing we're doing with the website is we'll try to update things on how the hardware activities are going. As I indicated, we have nominally identified that this Sunday we're going to attempt to do the first hot fire test with the whole vehicle all put together. That may or may not happen this Sunday. Hardware activities are some of the more strenuous ones in terms of things going wrong at the last minute. So we're still working that, but nonetheless, that will also be up. The video of that and the activities of that will also be up. So you begin to get an idea of the vehicle, at least the engine operating, the ACS thrusters and where they're located, which then translates back to the simulation environment to hopefully give you a better idea, a feel for how the vehicle flies in the simulation, and then be able to translate that to the real world for the vehicle itself. So great. All right. I think you can stop sharing, Garrett. We will. My guess is that there'll be a lot more questions after folks are able to sort of digest what's out there, and or we actually get all the documentation out so they can start looking at it. So again, don't hesitate to send an email or to reach out so that we can try to answer the questions. Don't want to cut folks off early, but if there's no additional questions, we definitely respect everybody's time. So we will probably end early. And again, no later than Monday. A lot of this information will be on the website, so you can go back and revisit it. Hopefully by Friday, we'll be able to get a lot more information up on the website and the weekend as well. So great. Well, I really appreciate everybody taking the time. It's sort of exciting. It's a lot of effort and a lot of work. We're actually hoping we're gonna get a lot more folks excited about it. We're glad that you guys joined us. Really, really appreciate it very much. And thanks, Jose and Andrew and Tan and Garrett for putting this together, and the entire team that's behind Leapfrog here to make this happen. So, all right, we will sign off, and we will talk to you guys at the next webinar that will be live. We listed that, I think that is April 30th. So it'll be the next thing that comes up. So you guys take care. Have an awesome day. Cheers.
Thank you.